All right, so in our group, our partners, we were trying to do the practice problems that Miss Sloan asked us to do, right, guys? So what we're going to do is we're going to go over some of the problems. Do you want to do them all together from now on since you aren't talking to each other? Okay, that'll be fine too. Okay. I'm in the right book. All right, so we are going to do practice problem number 54. And we are in our book. So 54 says, give an example of each of the following. An object that is slowing down but in a positive acceleration. Okay, so if we're looking for that, what is the car doing? It's moving backwards. Write this down. It's moving backwards at decreasing speed. Number 54A. Okay, an object is slowing down, has a positive acceleration, and I just told you it says if forward in a positive direction, a car is moving backwards in a decreasing speed. So the car is moving backwards at a decreasing speed. If I go too fast, let me know, okay? B says an object that is speeding up but has a negative acceleration. What do you think's going on here? Correct. The car is moving backwards and increasing the speed. Very good, Robert. The next question, we're on page 82 and we're going over the review questions. C says an object that is moving at a constant speed but has an acceleration. What's going on here? How about moving in a circular track, like a racetrack, right? At a constant speed. Does that make sense to you? Circular racetrack going at a constant speed. Is everybody good so far? A, ma'am, was that a car was moving backwards at a decreasing speed. Is everybody good so far? Okay, I'm going to go to 55 now. 55 says, showing the velocity time graph for an automobile on a racetrack, describe how the velocity changes over time. So what do we have? Are we looking at the graph? What's going on with the graph? Say that one more time. I didn't hear you. Right. But what's going on with acceleration? So I agree with what Raymond is saying. He is telling us we have this graph, right? We have velocity over here. We have time down here, right, in seconds. This thing is going up, up, and then curving, correct? Is that what our chart looks like? Okay. So do you agree that the car was at rest to start with? Had zero velocity. What happened over the time? He increased his velocity, but then what happens? Slowing down. Correct. Velocity is different than position, right? And that's what you wrote. Did anybody write something else different than that? Good so far? Okay. So that's the answer to that question. And what you're looking here is to see what the velocity is over time. So let's look at 57. 57 says, rank the task, the following objects according to magnitude and acceleration from the least to the greatest. Specify, indicates any types. All right. So what was your letters? What did you have? What do you think?
Let's say wait, no, B.
Okay. Can we do the math first? Are you ready? Oh, God. This was a hard one. All right. So the first one, it tells us a falling acorn accelerates from 0.50 meters per second to 10.3 meters per second at 1 second. Are we all good so far? So we are looking for average acceleration. I want you to write all this down. If we don't get to all the problems, it's okay. That's going to be the change in velocity over the change in time. Right, guys? Now, if I do the numbers wrong, you tell me. Okay? What is our average velocity that it says in the word problem?
1 second. Wait, hold on.
Change in velocity. What did he finish with? 10.3 meters per second, right? Because remember that change in V means velocity final minus velocity initial, right? We're going to subtract 0.50 meters per second. Does everybody see where I got that number from? Okay. And like Robert said, he said it was 1.0 seconds. I'm going to give you a minute and you put it in your calculator and tell me what your number is. And I don't want anybody to yell it out. I want you just to do it yourself. Now, you want to make sure that your calculator is not in scientific mode, because my first block was in scientific mode. You will want to make sure that you're in radian, not degree. Okay, so make sure you reset your calculator because theirs is going to be different. So you're going to do alpha y enter, right? You're going to do 10.3 subtract 0.50, 0.50 over 1.0. Did everybody get 9.8? Okay. So that is 9.8 meters per second squared. That's number one, right, guys? That's A. Correct? Now let's do B. We're doing average acceleration again. Change in velocity over change in time. What is my velocity final for my second problem? What is going on with B? Well, he's stopping, isn't he? He's going to rest. So if he's going to rest, what's my final velocity? 0 meters per second. And what did he start off with? 20 meters per second. And what was his time? Okay. Let's do the math. Alpha y enter. We got 0 minus 20 over 1.0. What did you get? Negative 20 meters per second squared, correct? Those of you that are joining us right now, we are on page 82. We are currently working on question number 57. All right, C. What are we looking for here? Same thing, right? Average acceleration. Change in velocity over change in time. What is my final velocity? 2.0 centimeters. Okay, and then what is my initial one? 0.40 centimeters per second. What is my change in time? Now, What do we see here? These are centimeters. These are meters. We got to change this to meters. How do we do that? 1 meter over 100 centimeters. If we do this, right, guys, the centimeters are going to change to meters. Is everybody good? Okay, go ahead. Put it in your calculator. Now, when you do this and you get down here, make sure you use your arrow over so you can get this number by itself, because these are separate, right? What'd you get? Yep, 0.032 is what I got, right? Meters per second. All right, let's look at D. So Raymond, what formula am I going to use? Yeah, what formula am I going to use? Same one we've always been using, right? Okay, so we got this. So what is my velocity final, Raymond? Yep. Thank you, sir. 4.3 meters per second. What's my initial one? He's 0, right. 0 meters per second. What's my time, Raymond? Okay. All right, let's do our math. Xavier, you're going to tell us what it is. Okay. I'll come see. Now, the first thing I want to ask you, did you check your mode, sir? Is it in scientific? Because we don't want it that. Yeah, you got to change it. That's why I said my first block class had it in. And so you want to change that to there and this to there, and your numbers will be right. Normal and radian. All right, sir? And you're going to put it in your calculator. Yeah, that's because it's scientific notation. Now, if you do second answer, it'll tell you the right one. If it's in scientific notation, it'll take it out.
You want me to do that?
Yep, tell me. 10.75, which you're going to say is 11. Very good. Yes. 11 meters per second. All right. E, Kristen, what formula am I going to use? Same one, right, Kristen? Same exact formula, okay? What is my velocity final? So it says here, jogger accelerates from 2 meters per second to 1 meter per second in 8.3 seconds. What is my final place? It's the 1, right? Yep, 1. So that is 1.0 meters per second, right, baby? What's my initial velocity? 2 meters per second, correct. Okay, what's my time?
8.3 seconds.
8.3 seconds. All right, put it in your calculator and tell me what you get. What? Kristen's going to finish it. It's okay. What'd you get?
Oh, that's a lot of decimals.
Yes, it is. But what's the first two numbers?
0.12.
Okay, so it's
Well, negative.
negative 0.12, correct? Meters per second. Now, Claire, tell me the order that it should be in.
C, E, A, B, B,
Okay, C should be first. I'm sorry.
E,
E is an elephant. A is an apple.
D,
D is in dog.
B.
And B is in boy. I'm telling you, if you can do this, you will know section 1. But were you doing all that to find it? Okay, is everybody good? Does everybody have everything written down? Because remember, we're having proof today that we did these problems. Raymond, do you have everything? Kristen, do you have everything? Claire? Bailey? Good? Okay. All right, so now we're going to go to what question is next? 59. Okay. 59 says the graph in figure 27 describes the motion of acceleration moving east along a straight line. Find the acceleration of the object from each of these times. Okay? Bailey, you ready? What do you think is number A for 59? What do you think you should do? We're doing the same thing as we did before that we just got finished doing, right, baby? So for 59, we're going to say change in acceleration equals the change in velocity over the change in time. All right. What is my final velocity on that graph?
30.
Yes, ma'am, you have this whole problem. So what is the final velocity? 30, okay. So 30, what is my initial velocity? Meters per minute, right? 0 meters per minute. What is my time? How long? 5. Okay. What is my answer? What'd you get? Yes, ma'am. So the answer to this is 6 meters per minute. But now we got to find out which way are they going? Which way are they going? Which way are they going, Bailey? East. Thank you very much, ma'am. Okay. So we've got positive, right? We've got, and remember, north, south, east, and west. Always got to remember that, right? Up is the y-axis. Straight across is the x-axis. Those are two things you've got to know. Everybody ready for the next one? All right, baby, you ready for B? Yep. So what do you think you got? So what are we doing here for B? Is we're saying that between 5 and 10 minutes, right, baby? Okay. So we're doing our change in acceleration again, change in velocity over change in time. What is my final velocity? 30. What was my initial velocity? 30. Yes, ma'am. I know it seemed weird, but it is 30. Okay. What is my time final? Yeah, we'll get 10 and we're going to minus 5, right? Is that seconds? 5 seconds? Okay. What do we have? What's my answer? Zero. Very good. Thank you. All right, Robert, you ready to do C? Okay. So C is telling us that we need to between 10 minutes and 15 minutes. Are you ready? All right. So acceleration equals change in velocity over change in time. What is my final velocity?
30.
What is my final velocity? 20.
20.
Okay. And you're right about the final, which is 30, right, sir? Okay. All right. What's my time? What's my final time?
15 minus 2.
15 seconds minus what?
5 or 10?
10.
10.
Okay. Put that in your calculator. We are currently working on page 82. We are currently on question number 59, guys. No, it's okay. What is it? No, do you have a fraction still? Okay. It's all right, Robert.
Negative 10.
Okay. Did everybody get 10 or did you get a different number? I'm talking for C. -2, right? Okay. I just showed him.
Yes, and negative 2.
Oh, you did say -2. Why, I think you said -10. God bless. Meters per minute. Robert, just slap me. Okay. We're at D now, right? Is there a D? Yes, Xavier? What we got?
Wait, there isn't? Oh, okay.
Okay, what do you got, Xavier?
59, right?
Yeah, we're still going. Tell me what the change in velocity is. What's your velocity final, sir? What's your velocity final? 0, thank you. How about our velocity initial? 20? Yep, that's right. Okay. What is my change in time? Okay. All right, sir. What's my math? What do I got? She's got it. Leave him alone. No heckling from the gallery. -4. Okay. Now, how do you feel about that? Feeling good. Do you think we need to stay in section 1 or should we go to section 2? This is what I want to do. If you feel confident in section 1, I want a thumbs up. If you want to do another problem, I want you to do thumb sideways. And we got to do a couple more, do butt down. But I'm going to take a poll in the class. What do y'all think? Okay. 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 All right. Fantastic. The greater wins. Okay, so we're going on to section 2. Where's our first problem in section 2?
63.
Okay, 65. The one that I asked you to do, yeah. Out of the group. 65. All right, go ahead. So let's see what we got. Because we're running out of time. Yes, okay, good. Okay, so 65 says a car moves forward up a hill at 12 meters with a uniform backward acceleration at 1.6 meters per second squared. What is the displacement after 6 minutes? What is the displacement after 9 minutes? So go ahead and take that problem, see what you think. Write down, if you don't know how to go anywhere, at least write the variables down.
Does 65 go with that graph?
Oh, Lord.
So a car is moving forward at the hill at 12 meters per second. That's my velocity initial. With a uniform backward acceleration of 1.6 meters per second. Okay? The first problem asks us for 6 seconds. The second problem asks us for 9 seconds, right? Did you get those variables? In section 2, what equation we would use for this?
The velocity final.
Position final.
Position final.
Because we're trying to find the position, right? Okay?
Oh,
Equals velocity initial, time final, plus 1/2 of the acceleration times final squared. That beautiful equation. So what I want you to do now on your own, I'm going to give you a few minutes. I want you to take this because this is kind of like what the test is going to look like. Okay? Just the math section of it, which is very small. Were you able to know that's what those are for? Because you'll have to know what these variables are. Okay? From reading the problem. I'm giving you the formula. Now that you've got the formula, can you plug and chug and give me the answer? What is the main thing that I want you to remember about this problem? What is the one thing I want you to make sure you understand? What is it? That square here.
yeah.
Do not forget the square. You see these squares here? There's part of the unit. That is not. So what I'm going to do is give you a couple of minutes. You're going to work on both of these problems. And when you get your answer, we're going to go over them together. But I'm going to give you a minute. So go ahead. Work on those. Yes, ma'am. Yes, you do. So this is what happens, right? You ready? You're gonna put your velocity one, right, within brackets. Put your time final in brackets, okay? Then use your plus sign. Alpha Y enter to get your half. Okay? Open up your bracket again for your acceleration. Close your bracket. Open your bracket for your time final. Close your bracket and put a square on the outside. So you've got velocity, time final, plus 1/2. Your acceleration. Then you're gonna have your time final. You have yours in scientific. Did you get failed? Is your answer? Get failed.
Well, I got that first, but I'm not splitting.
Okay. Okay, I'm gonna write this out and then I'm gonna do it with my calculator and you can do it with me if you want. So we have 12 meters per second times 6.0 seconds plus 1/2. Now, when you're doing that 1/2, either you can do it as a fraction or you can do 0.50, but don't do 1 divided by 2 because that's not going to work. Okay? Open bracket, 1.6 meters per second squared times, and then 6.0 seconds squared. Okay? Are y'all ready? Whew. Okay. 12, open bracket, 6.0, close bracket, plus sign, alpha Y enter, 1/2, move my arrow over, open bracket, 1.6, close my bracket, open bracket, 6.0, caret 2, close bracket. I got 100.8. Did you get 100.8? Everybody good?
We're not gonna talk about it. I see what I did wrong. We're not gonna talk about it. Let's see what I did wrong.
No, it's okay. That's okay. I'm figuring mine back out again. No, it's supposed to be in radian. I don't think I did negative 1.6, guys. So what you got, what'd you get?
43.2.
Yep, it's 43.2 is what I got this time too, when I finished it. How do I delete right there?
It worked whenever I did 1 divided by 2.
It did?
Yes, ma'am. I did it both.
The answer is 43 meters, 43.2. Everybody good? All right, how about this one over here? What are you getting? This time, the only thing you got to do Remember how we do this. Arrow up to your last answer, right, guys? What are we going to change? 6 seconds. That's all we're doing. It's going to be the exact same one, except this time, instead of that number, we're putting 9. Tell me what you get.
42.2.
Okay? That's it. Our goal is 43. So much easier to blame a calculator.
Oh,
Everybody good?
oh, yeah.
Man. Hey, you want to go to the restroom? Please. Can we go to the next problem now? Okay, I'm waiting. Those of you that are ahead, go ahead and go to 68 while you're waiting on me. He's putting it in his calculator. There might be something wrong with your calculator. We might need to recalibrate it. Raymond, did you get the right answer yet for him? Okay. Let him look at it. What was he doing wrong? Oh, you didn't see his problem. All right, number 68. Are you ready? Is that where we at? 68. Referring to figure 29, find the magnitude of displacement during the following time intervals. Round answer to the nearest meter. Raymond, I think you're first. How about an A for number 68? Yep, 68A. Yeah, we're doing another one now. Okay, are you ready, Raymond? Can I help real quick? So it says, refer to 29 to find the magnitude of displacement during the following time intervals. Round to the nearest meter. Okay?
I don't think this is the same. This ain't the same.
It is not.
Yeah.
We are doing area. Can I do the first one, Raymond, and let you do the number 2? Okay. So the area is 1/2, and we have 5 meters per minute times 5 minutes. So what is the answer, sir? Just do the calculation. While he's doing the calculation, I'm going to explain it. So what you're going to do is you're going to look at your time 5 and your time 10. Okay? You're going to go up to where your line is, and you're going to shade underneath. Okay? That's the area, right? That's what we're trying to do. Shade underneath, and that's where I got those numbers from. Nope.
Is it 88?
88 meters. It's okay. It's okay. We got this. How we doing, Raymond? 1/2 of 5 times 5. 1/2 of 5 times 5. That's what it says there. So if we look,
You said half of 5 times 5.
I did not finish it. It's my fault, Raymond.
Oh, it's a
Do
15?
the math. Yes,
Oh.
I didn't finish it, Raymond.
Is
So the top one supposed to be 15?
It's all together.
Oh, no.
His number was right, but I did remember.
87.
5 times 5
107,000
Plus-
feet.
15
What?
times 5. I got 87.5, Raymond.
I can convert from decimal.
Well, if it's a half, it's 0.50. All right, are you ready for number 2? We're gonna do, I tell you what, are y'all done? Y'all wanna do one more? If not, we can let Haley off the hook and everybody else at home. Do you want to do one more, or do you feel, because you're gonna have this. Do you want to do another one? Okay, sounds great. Let's do another. So I just want to make sure. So that's the first one, right? So that is A. So now it's asking us for the area. Okay. So if this is 88 meters, and for answer B, it's asking us for the area of 15 meters per minute times 5 minutes. What is my answer for that? 15 times 5 is 75. Okay. Okay. So do you want to do the next one, C? Let's do the C. Ready to do C? So it's asking us for C. Is this asking us for 25 minutes and 30 minutes, right? So we have 1/2 of 5 meters per minute times 5 minutes. What do we get for that one? Yeah, 12.5, which I'm going to round up to 13. Okay, let's do D because this is just like A, right? Right, Robert? Okay, we're going to do D. So D says from 0 to 25 minutes. A long period of time, isn't it? 1/2 of 20 meters per minute times 5 minutes plus 88 minutes plus 75 minutes. We're taking this number and this number. Do you see where I got those numbers from? All right. Robert's going to do this one. He's going to tell us what the number is.
So let's see what happened. We got 232.
Hold on, I ain't done yet. You might have to stand up to see this. Yes, ma'am. You can. You don't have to ask.
But you're not done right now.
No, I said I wasn't done yet. All right, now tell me. I had to do all the areas. That's a big thing. From 0 to 25, that's almost the whole chart.
Dang.
So it's a half of 20 times 5 plus 88 plus 75 plus 1/2 of 10 times 5 plus 5 times 5.
Is that even necessary?
You have to do every single area.
263. I got it wrong here.
So what did you miss? So take 288 from that and tell me which one you missed. Just take that answer and take 288 from it. Tell me what you were short. So you missed a 5 times 5 somewhere. That's all you did. Close this book. Put it over there. God bless you. Don't cry when you get home. It's okay. All right, guys. So tomorrow, those of you that are at home, we are going to put the test live at the same time. The test people that are in here taking the test. Remember, your test has to be turned in at the end of class like everyone else. Now, if you do not turn your test in at the end of class, it's automatic 20 points off if it's late. If anybody has any comments, please post it in the comment section because I can't hear you. If you don't have any questions, you're free to go. Yay, I'm glad you're going to be back here tomorrow. I hope we're going to be here with you.